Hi, my name is Maithreyi,
And I'm Cassidy.
and today we are going to be talking to you about a circuit that we built. It's called a boost converter circuit. It's a DC to DC converter that is basically enabling this motor right here to run. We are using two different ways to alter the speed of the motor. So we can either change the input voltage into the circuit, which is this one right here, or we can change the ratio of resistances by adjusting this trim pot right here. As you can see, there's this little screw that we can turn around to adjust the ratio of those resistances. And doing either or both will change the output voltage, and therefore will change the speed that the motor is running at. So now Cassidy is going to explain how the circuit works.
Okay, so circuit diagrammed here, the switch, inductor, and all that. When this switch is open and allows current to go through here, the impedance is lowered, and therefore the current through the inductor is higher. And so then when the switch is turned off, the inductor will resist the change in current from that and push the current through this motor, which means, or through here, which means a higher voltage, more charge. And then the capacitor here stores energy, the energy that goes from there, so that it keeps it at constant voltage. And then the other important part is that the 555 oscillator be at a high enough frequency that the period is small enough that neither the inductor nor the capacitor are able to discharge during that time, so that everything stays steady and constant, and current is not dumped through the MOSFET, causing it to overheat.
Yeah. So if you'll notice right here, we have this, which is called a heat sink, and that's on our MOSFET. So the MOSFET's actually underneath this. You can't really see it. But one of the purposes, the purpose of that is to reduce the heating up of the MOSFET. So for one, we did change this capacitor right here in order to make the frequency higher so that MOSFET wouldn't heat up, as Cassidy was saying. And then in addition, we put the heat sink on to completely eliminate the possibility of that heating up too much. So that is the purpose of the heat sink right here, and the MOSFET is right under. So that is our circuit. And this is traces on our oscilloscope.
Yes, so channel 2, the blue line, is that is the voltage across the motor. As you can see, it actually is a DC voltage because of the capacitor and all that keeps it constant. The second one, or the purple line, is the 555 output, and the green line is the voltage at the end of the inductor.
So those are the traces on our oscilloscope, and just a quick demonstration. You can hear the motor speeding up here, but this is what happens when you increase the input voltage into the circuit. It speeds up, and then also, yeah, and you can also see the voltage here. And then, Cassie, do you want to change the trim pot?
Yeah.
So here we're adjusting the trim pot, and you can hear at least that the speed of the motor is changing by adjusting the trim pot right there. And that is the boost converter circuit that we built. Hope you all enjoyed it. Thanks for watching.